So section 2.4 is all about modeling with quadratic functions. The easier way to say that is by writing equations. So in your book, you are going to see the words modeling with quadratic pluses. You're going to be famous now. Yep. I haven't even looked. I probably have like 3 views on the one. I actually, I was looking at the, like, you know how you can go to your, actually, you probably don't, I don't know if you know. There's a YouTube channel thing where you can look at stats. Yeah. And like, one of the things, you know, because I posted your first couple videos on YouTube, and like people watched them, and it had like, I don't know, 70 or 80 views or something, and I was up 999% in the last month. Felt pretty good. Paycheck is coming. All right. So there are 3 different things that we really need to talk about. There are 3 ways that we can write parabolas. Remember, parabolas have to have 3 points. Okay, so this is all about writing the equations of a parabola given certain things. We just spent the last section in 2.3 talking about how to write equations of parabolas when given the focus and the directrix. We talked about those 2 things. Now we're talking about what happens if you're not given the focus and you're not given the directrix, because that changes things a little bit. So you have to have 3 points for a parabola. The options that you can have for a parabola, you can have the vertex and another point. You can have the intercepts and another point, or you can have 3 random points. Those are the 3 things. And notice how that coincides exactly with the 3 different forms that we spent time graphing with, right? Intercept form, vertex form, and standard form. So the first one is, if you are given the vertex, and we'll go through an example of each of these, but if you are given the vertex, you need to use the equation y equals a times x minus h squared plus k. So you have to use that. And I should say if you're given the vertex and a point. So in this case, you really only need 2, because remember, if you know the vertex and you know another point, then you really could find a 3rd point because of the axis of symmetry and that reflection, right? The second one is if given the intercepts, and I'm going to put x-intercepts there in a second. If given the x-intercepts and a point, you need to use intercept form. And remember, what I'm going to give you guys on your test on Tuesday is I will give you these general forms. So like I will give you this, and I'll give you this, and then I'll give you the equation for standard form as well, but I'm not really going to tell you anything about those. Okay, so that way hopefully you don't get them confused and mixed up, but you still need to know the applications with them. The last one is easily the most difficult, and it is easily the most work. This is if you are given 3 random points. Now, I think I need to say this. I think you're all smart enough to figure this part out, but I just want to cover myself with this. They have to be on the parabola. So when I say 3 random points, I don't just mean 3 random points on the graph. I mean 3 random points on the parabola. Those are points that are not the vertex and not the intercepts. Okay? So if you are given 3 random points and you are given something that is on the parabola, then you need to use the equation y equals ax squared plus bx plus c. Okay, and now this is the part that's no fun. So this is the part that's no fun. With all the other ones, it's basically just a plug and play. You remember how you did y equals mx plus b? If you're given the slope and you're given another point, you just plug those things into the formula. And then once you plug them into the formula, you just work things around and you solve for b, and then you've got your equation. That's how the first 2 equations like this work. You're given the information, you plug the things in, you plug another point in to find out the other information, and you're done. This one, this 3rd one, is a lot more challenging, because what you need to do on this one is you need to create a system of 3 variables. So that means that you have to have 3 equations. And solve for A, B, and C. So this one is by far the most challenging. It's the most work, it's the most challenging, it's difficult, it's just something that is tough. But the thing is, you already should know how to solve these things because we did that in chapter 1. That was one of the questions that you had on your chapter 1 test, was the ability to solve a 3-variable system of 3 equations. Okay, so that's something that you should know how to do. That's something that you should be able to work your way through. All right, so we're going to just kind of jump into examples because there's really nothing else to do. Those are the 3 things that we're going to talk about in this section. So we're just going to kind of jump into examples. Okay, so this first example is a little bit tougher, but it kind of just gets us right. It makes us hit the ground running. So let's say, and this is going to be a word problem, so I'm going to write this out. A person is shot out of a cannon. "20 feet above the ground. He reaches his max height. Does this seem like physics?
Yeah. The max height trajectory.
Well, we actually know the max height right here. Oh, is traveling spelled with 1 or 2 L's? So this is a lot of parts to it. Okay, this has a lot of things and a lot of issues that we need to kind of to run by. Okay, so the first thing is, notice that this person is shot out of a cannon 20 feet from the ground. He reaches his max height 30 feet after he's traveled 25 feet. Then he lands in a net that is 60 feet away. And it wants to know how high off the ground that net actually is. So the easiest way to think about these problems is to actually draw a diagram. I know that that's the first step that almost every math teacher ever says when you have a word problem, is draw something, right? But this, in this case, this actually will help you a lot because it'll actually let you think and understand more about this. So if I draw my picture of a parabola, I know that this guy starts here and he is then going to be shot out of a cannon. Now, obviously, we're talking like this is a parabolic shape, right? Because if he's going to be shot out of a cannon, he's going to go up for a certain amount and then he's going to start coming down. And it's not an absolute value because he's not going to shoot straight up and then straight down. This is going to be a gradual increase and then a gradual decrease, right? Okay, so I know for sure that he is going to reach his max height after traveling 25 feet. And his max height is 30. I know that he started at 20, and I know that he is landing in a net that is 60 feet away. Right? So I've done nothing other than put what was in the actual paragraph onto a picture. But I should be able to come up with quite a few different things about that. Now, if I'm trying to figure out exactly how far away something is or how high up something is, then the best way to do that is with an equation. Now, am I given any specific or good points in this graph? Or am I given any points at all? Go ahead.
You have the vertex.
I know the vertex, right? Which is what? So right now, I'm going to plug this into that first thing. Remember that first thing I wrote where if you're given the vertex, then use this equation? I'm going to plug that in and then see where that takes me. Okay, so I'm going to plug that in and see where I end up. So I'm going to use y equals a times x minus what goes here? 25 squared plus 30. So right now, this almost looks like a real equation, right? Almost. It's super, super close. But I'm missing one thing. A lot of you on your quizzes spent a lot of time trying to figure out how to get rid of the y's and x's. Do I want to get rid of y's and x's in a quadratic function? No. That's the thing that creates the function, or the y's and the x's. What do I need to get rid of here? The a. So this is exactly like when you're doing y equals mx plus b. Most of you are able to find the slope first, and then you have to plug points in to find b. That's the exact same thing that's going to happen here. So what I need is another point. I need to find another point. Do I have another point? Go ahead, Zach. 0, 20. 0, 20. It's where he starts, right? He starts at 0. Wherever 0 is, that's where his starting point is, and he's 20 feet off the ground. So this thing right here tells me that his starting point is going to be 0, 20. So now I'm going to take that and plug it in here and solve for A. So I'm going to plug 20 in for Y. I don't know what A is, so A stays like that. And then I get 0 minus 25 squared plus 30. So then I'm going to end up getting 20 equals 625A plus 30. I don't know what negative 10 over 625 is. Does anyone have that? Does anyone have a calculator out and ready? And I think my math is right. I'm not positive.
Negative 0.016.
So I found my A value. Okay. Now that lets me write my equation. If I can write my equation from that, that should be pretty straightforward, right? So I get Y equals negative 0.016 times X minus 25 squared plus 30. Now the question is, like that was pretty much the first part. That's the most important part of this question. Because once you figure out the equation, then you can really move on and you're good to go. So if I'm plugging something into this, it will then spit out an answer to me. What do I have to plug in and where do I have to plug it in order to figure out how high this net is off the ground? Go ahead, Tanner.
Plug in 60 in X.
Plug 60 in for X because, right, that net is 60 feet away. This distance, the horizontal distance, is the X value. So I'm going to plug X in, or I'm sorry, 60 in for X. So I'm going to get Y equals negative 0.016 times 60 minus 25 squared plus 30. This will never, ever, 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 ever be a question I ask you to do without your calculator. Never, ever. Okay? So trust your calculator on this as long as you know you're not making any mistakes. Okay? And if you guys would calculate that and compute that for me, that would be awesome. Did you get Dana?
10.4.
So 10.4 feet off the ground. So this thing is 10.4 feet off the ground.
Would you do it?
Would I do it? Get shot out of a cannon? I don't know. Something I've never really thought about. Sure, why not?
We're in
Produce the cannon.
produce
As soon as the cannon gets here, I'll be the first one to do it. As long as, actually, hang on though. It has to be safe because if somebody just like, you know, brought a cannon, it's like, hey man,
This is a circus.
you told us you'd do it. You're a liar. All right, so this one is going to be a little bit easier because I'm not going to make you do a word problem. Oops. I want to write the equation. So I'm not going to make this super specific or super exact on my sketch. I'm just going to put the points down where the points are located so that way you can see them. Okay, so this one gives you your intercepts, right? Now, I specifically chose this example because there are 3 intercepts that happen in a lot of cases of parabolas. Not all of them, but a lot of them. Okay, there are 3 intercepts that can happen. There's 2 intercepts that happen here. Those are called the x-intercepts. And then there's 1 intercept that happens here. I want to use the x-intercepts for the equation y equals a times x minus p times x minus q. I want to use that. Okay? I do not want to use that red point. That red point is the y-intercept, and it tells us nothing about intercept form, period. Okay? It tells us nothing about that. So just keep that in mind, that that is not something that you can use, okay? For this intercept yet, or for this form yet, okay? So if I'm coming up with this equation, I know that one of my x-intercepts is 6, right? And I know that the other one is 21. So I'm going to do the same thing that I did last time, and I'm going to plug those into the formula and then see what else I can solve with whatever I end up with. So I'm going to get y equals a times, now this is tricky. I'm going to give you a second to try this. Make sure that you remember it or see it or understand it or know what we're doing. When we plug those in, what do they look like? X plus 6 or x minus 6? It's got to be x minus 6. Is it x plus 21 or x minus 21? Minus 21. Right? Those are very important. They're opposite. Remember, your intercepts are always opposite because they're inside the parentheses. Whenever you get something out of a parenthesis, it is going to be the opposite. Okay? Now I just need another point because then I can figure out my a value, right? So once I get that other point, I can find out my a value. So if I'm going to grab my other point, that's where this point is going to come into play. Okay? So I know I'm going to have the point 6.3 equals a times 0 minus 6 times 0 minus 2. So that's 6.3 equals negative 6 times negative 2. Negative 2 is positive 12.
It's supposed to be 21.
Oh, yep, you're right. Thanks. Good catch. Yeah. Where are all the rest of you guys, huh?
I was gonna say.
Yeah,
something, but I
okay.
didn't wanna
Yep.
sound concerned.
Yep, sure. What is that, 126 then? You're the only one that cares about me, Grace. Now divide by 126. So then I get a equals, what is 6.3 over 126? 0.05. Okay, so I've got my a value, and now I can just rewrite that into my equation. Y equals 0.05 times x minus 6 times x minus 21. Now I'm not taking your calculator away from you on this, so if you were smart and you have time, you should type this into your calculator, and then you'd be able to see if your equation that you wrote produces intercepts that are the same. Now, if you had to round this at all, it's probably not going to be exact, but it should be pretty dang close. Okay, so that's what I would do if it were me and I had the time to do that. Okay? Does anyone have any questions over these two? All right, we're going to pick up the other one of these on Monday so that we have a little bit more time to go through an example, and then you guys will have some time to review and go through your practice test on Monday. Okay, so we'll go through the other one of these. There will be homework on Google Classroom for you to attempt if you'd like to do that. But that should be it.